The next service that we're going to take a look at is the Relational Database Service, otherwise known as RDS. RDS is a managed database service provided by AWS, and it supports a number of traditional relational databases. These are the types of databases that most people are familiar with, where you have a database that has one or more tables, and each table has one or more rows in it. And you can join sets of data together by joining rows within multiple tables. The RDS service supports a number of different relational databases, anything from MySQL to Microsoft SQL Server, Oracle, and Aurora, which is AWS's custom database. The Aurora database is kind of special in that it supports and is compatible with both MySQL and Postgres. So the Aurora API is compatible with both of those database systems. When you launch a database using the RDS service, essentially what AWS is providing is an endpoint that you can use to access that database using an application. When you launch a service using RDS, launch a database, you can, of course, access that database via your application, and any data that you store in the database can be backed up. There are two different database backup schemes which you can implement. By default, RDS implements an automated backup schedule, so you can automatically back up the data in your databases on a scheduled basis. You can also perform ad hoc snapshots of data. So if you want to take a quick snapshot of a database, then you can actually take that snapshot and use that to launch essentially a cloned copy of your database, which is a pretty cool feature. In terms of the automated backups, the RDS service will back up the data in your database on a daily schedule, and it will retain those backups for up to 35 days. You can, of course, not only is it storing the data, but it's also storing the transaction logs for the database as well. And when you perform when you recover from a backup, what will happen is the RDS service will actually replay those transaction logs. So that ensures that your database is consistent. The data which is backed up from RDS is actually going to be stored on S3, and you have the ability to determine the backup window during which the RDS service will back up your databases. For example, you might want to back up the data in your databases during an off-peak hour of the day, because when you are backing up the data in your database, that may slightly impact the I/O performance of the database. So you wouldn't want to back up the database during sort of like a peak time of the day. You'd want to pick an off-peak hour. The RDS snapshots are ad hoc, and they're going to be initiated manually. And those backups will exist indefinitely. Even after you delete your database, you can retain those snapshots. And oftentimes we'll use snapshots to make a clone of a database. For example, maybe we need to copy a database and use it for some sort of testing purposes. Or maybe we want to create a staging environment by cloning a copy of production data and doing some testing in the staging environment. We can do that using RDS snapshots. Now, generally, databases are a critical infrastructure component for any application. And the resiliency of the database plays a key role in the resiliency of the overall platform. You could have a sort of a web application front end, your platform, which is running on multiple web servers and is load balanced. But if all of those web servers are communicating with a single backend database instance, then the availability of the platform is going to completely depend on the availability of that one single instance. And we know that that's never a good situation, because if that one instance lives in a single availability zone, and if that AZ were to fail, then the entire platform would fail. And so when we deploy our databases, especially in a production sort of architecture, and we need to support a highly resilient and highly available application, we want to deploy our database service into multiple availability zones. And RDS supports this using a feature called multi-AZ compatibility. And what RDS will do is, when it launches your database server in an availability zone, it will launch a standby database instance in a separate availability zone and use that secondary instance for failover. What happens then is, when your application is writing data to your main database server, those database changes are synchronized to the standby database, which lives in a separate availability zone. If your primary database server fails, then RDS will automatically redirect database requests to the standby instance. And that provides you with much greater service availability. Of course, that comes with an additional cost. So if you were just wanting to test a database in a sort of a development environment, then you typically wouldn't bother with spinning up a multi-AZ sort of configuration. But certainly in a production scenario, you would almost always want to run a multi-AZ compliant sort of architecture. One thing to note is you might have multiple database servers and multiple AZs, but that doesn't actually increase the performance of your database service. It just improves the availability and the resiliency of the service. Pretty much all the different database types that are offered by RDS will support a multi-AZ architecture. The Aurora database service is kind of special because this service was specifically designed by AWS to run in the cloud. And it's the only service which is only offered in a multi-AZ sort of architecture. What's interesting with Aurora is that when you spin up an Aurora cluster, it will launch 2 database instances in 3 different AZs. So 2 database instances in each AZ, and running instances across 3 AZs. So that means that you have a total of 6 database instances in an Aurora cluster, which means that it's extremely resilient, and it also offers very, very high performance. I mentioned earlier that just because you're running multiple servers in a multi-AZ sort of architecture, that doesn't necessarily improve performance. Well, with Aurora it does, because of the way they've designed it, but with other traditional databases, it doesn't improve performance, essentially because all the reads and writes are hitting the main database server, and you have a secondary server which just exists for redundancy purposes, but it's actually not serving any requests unless the primary server were to fail. Well, if you need to scale up the read performance of your databases, and frankly, most databases are read heavy versus write heavy. If you need to improve the read performance, you can create what are called read replicas. And these are additional database instances, sort of mirror copies of your primary database that live in separate availability zones. And they will asynchronously copy data from that main database. So they'll replicate that data. And so what will happen is that your applications, when they're reading data from the database, they can not only read that data from the primary database server, they can also read that data from any one of the read replica databases, which means much greater performance because all the reads are being distributed across a set of servers. All of the writes are still going to one server. They're all still going to that main master server, but the reads can come from any one of the read replica servers as well. You can create up to 5 read replicas, and if you have a read replica, you can actually, if you want to, you can promote it and have it become essentially a separate database, which effectively splits the relationship with the database master that was previously cloning data from. So that's kind of another way that you could replicate a database and kind of clone it is by creating a read replica, synchronizing all the data, and then promoting that read replica into a new separate database instance, essentially.